The challenge of jack coupling makes us to develop the advanced technology. The creativity of jack coupling opens a prosperous future. The challenge spirit of jack coupling leads to the global top technology. Gear coupling. Jack's gear coupling is in compliance with the requirements for gear-type shaft couplings of KS, and other standards are designed to provide higher performance based on the best use of accumulated technical experience and field tests. Jack's gear coupling is smaller and lighter than its competitive models of the same horsepower and generates almost no noise and vibration at a high-speed operation. Grid coupling. Jack's grid coupling reduces vibration and impact load as the flexibility of the grid absorbs the impact, vibration, and overload generated from operation of machines due to the flexibility of grid. The point of application of force vibrates inside the curved surface of the tooth. Even in the case of parallel error, angular error, or axial error, the coupling reduces vibration and impact and transfers power easily. Wind turbine coupling. Wind turbine coupling designed for wind power generation. With the built-in torque limiter, Jack's wind turbine coupling uses high elasticity compound materials or steel materials to provide the best insulation performance. Tire coupling. Jack's tire coupling is a natural rubber-coated product which reduces impact and absorbs vibration when transferring power. Jack's tire coupling requires no grease and is inspected without necessity of disassembly. Jaw coupling. Jack coupling produces a wide variety of quality products, including jaw coupling, which is designed to be flexible against torsion to transfer power in a secure manner. Disc coupling. Elastic disc coupling, which is a lamination of thin sus plates of the same thickness. Rubber coupling. Rubber coupling, which transfers power with highly elastic and flexible rubber. Muff coupling. Muff coupling, which is renewed and reinforced with stable nodular graphite cast iron. Wire drum coupling. Wire drum coupling, which is a technology-intensive product designed to connect the wire drum to the decelerator of a crane or a hoist. Jack coupling is repaying customers' confidence, producing various and high-quality products.
Welcome to Lovejoy, where today we would like to demonstrate the proper installation procedures for the Lovejoy standard grid coupling with a vertical split cover. This installation video will show the basic procedures for installing this coupling. For this installation, please make sure you have access to the latest copy of the Lovejoy installation guide for this coupling. The installation guide can be found online at Lovejoy's website utilizing the Resource tab. Then follow the link to the installation instructions. Once you locate the installation guide for the coupling you are installing, just click on the PDF icon to download the guide. This installation guide contains important details such as charts showing the allowable coupling misalignment and torque settings for tightening the set screws and bolts. Some installation guides may contain additional performance and dimensional information important when confirming the accuracy of the coupling selection. Let's look at the necessary tools we will need to perform this installation. A lockout tagout kit, safety glasses, a calibrated torque wrench, Allen socket to fit the set screws, socket for cover bolts, an open or box end wrench for the cover bolts, a flat blade screwdriver, a soft face mallet, a straight edge, a dial indicator, vernier calipers, a micrometer to confirm the shaft sizes, a putty knife, a fine-tooth file, a strip of emery paper, non-flammable cleaning solvent, a clean cloth, and rubberized gloves. Prior to starting this installation, it is always important to ensure the equipment is in a safe and disabled state to prevent any accidental startup. Because of possible danger to the person working on the equipment, you should always consult all applicable federal, state, and local regulations covering the safe operation and maintenance of equipment. This includes, without limitation, the lockout-tagout procedure defined by OSHA. The Lovejoy grid-style coupling is ideal for connecting an engine or electric motor to fans, blowers, compressors, pumps, and other devices where some dampening of equipment vibration may be required. The grid coupling can dampen as much as 30% of vibration or shock loading when properly sized. The following components are provided with the purchase of your Lovejoy grid coupling with vertical split cover. You should have 2 standard grid hubs, a grid spring, 2 cover halves, 2 seals, a gasket, and hardware. Please note that the grid springs for larger couplings are made with multiple segments for ease of installation, such as this size 1080. When you receive the coupling, you should inspect each component to ensure that there are no visible defects, cracks, or damage from shipping. You may want to check the bore size for accuracy prior to continuing with the installation. If the shaft and the hub both have keyways, make sure you have the appropriate key ready to use when performing this installation. Ideally, the keys should be the same length or slightly longer than the hub to transmit the maximum allowable torque. Even though we have disconnected the power to this system, it is always a good idea to check and ensure that the power is off. If not done already, you should measure the shaft and ensure that the shaft diameter matches the coupling bore size. Then inspect the shaft and clean up any nicks or burrs from the keyway or shaft diameter. A fine-tooth file can be used to clean burrs from the edge of the keyway or large dents in the shaft. The emery paper can be used to clear the shaft of rust or any fretting corrosion. Finally, using our cloth and cleaning solvent, we need to ensure the surface of the shaft and the keyway are clean and free of dirt. The hubs, the grid spring, and the cover accessories should also be cleaned to remove any coatings used to protect them during shipping. Before installing the hub, lightly lubricate the seals and slide one seal into each of the vertical split cover halves. The vertical split covers will not fit over the grid teeth on the ends of the hubs and need to be placed on the shafts prior to installing the hubs. Place the key in the keyway on the shaft. The key should fit snugly in the keyway with no side-to-side movement. The end of the key should line up with the end of the shaft and the hub once the hub is installed. Please note that the Lovejoy grid hubs sizes 1020 through 1090 are manufactured with 2 set screws and a clearance or slip fit. These hubs should slide onto the shafts with little or no difficulty. Hubs for coupling sizes 1100 and larger are manufactured with an interference or shrink fit, and the installation guide contains details on how to prepare these hubs for installation. Regardless of size, the keys and the hubs should be flush with the ends of the shafts when installed. The grid hubs we are installing are manufactured with a clearance fit bore and 2 set screws. With the torque wrench, we will tighten the set screws in both hubs to the torque specified in the installation guide. The use of a torque wrench is important. If the set screws are not tightened enough, the hub could work loose and slide on the shaft. If the set screws are too tight, they could damage the key, the shaft, or the hub. Carefully move the equipment into position until the distance between the hubs match the gap dimension listed in the installation guide to within plus or minus 10%. This can be done with the use of a spacer bar that is the same thickness as the gap, or by measuring the separation with vernier calipers. The angular and parallel alignment of the equipment shafts is critical to the life and performance of the grid-style coupling. The maximum angular misalignment is only 1/4 of a degree, and the maximum parallel misalignment is listed in the installation guide. To check the basic alignment, start by laying a straight edge across the major diameter of the hubs. The maximum allowable parallel offset should not exceed the amount for your particular coupling size as specified in the installation guide. The angular and axial alignment can be checked using either a spacer bar or vernier calipers to measure the gap between the faces of the hubs. If space permits, this measurement should be taken as close as possible to the edge of the grid teeth at 4 different locations around the coupling: 3 o'clock, 6 o'clock, 9 o'clock, and 12 o'clock. The difference between any 2 of these measurements should fall within the range specified in the installation guide under the heading Angular. If the deviation exceeds the angular value specified, you will need to realign the equipment to correct this condition. If using a dial indicator to check the parallel alignment, mount the indicator on the driver's shaft with the sensor touching the hub on the opposite shaft. Rotate the shaft with the indicator to the 3 o'clock, 6 o'clock, 9 o'clock, and 12 o'clock positions and make notes of the deviation on the dial. If this deviation exceeds the value in the column labeled parallel, you will need to realign the equipment to correct this condition. The grid spring is a major component in this style coupling. The grid is made of spring steel and rides in the grooves located on the ends of both hubs. Torque is transmitted between the 2 hubs through this grid spring. The flexing of the spring allows the coupling to accommodate misalignment and dampen vibration. In order for this to happen, the metal grid spring rubs on the teeth around the hub, resulting in friction and the need for lubrication. The lubrication used must be a qualified coupling grease. Lovejoy provides a list of acceptable lubricants in the installation guide. Grease is provided with coupling sizes 1020 through 1090. To install the grid spring, you will need to rotate the hubs so the teeth of the hubs are in line, then smear a light coat of coupling grease around the teeth on the hubs. Carefully wrap the grid spring around the hubs, lining up the grids with the hub teeth. The grid spring will need to be stretched slightly and nudged into the slots using a flat blade screwdriver, finishing with a soft-faced hammer. A regular steel-faced hammer will damage the grid spring and possibly the teeth on the hubs and should not be used. When the grid spring is completely seated, take a putty knife, preferably one with a soft blade, and smear the remaining grease around the outside of the grid spring. Slide the cover halves over the hubs, keeping the gasket between the cover halves and the holes lined up for the cover bolts. Insert the cover bolts through the cover halves and gasket and hand tighten the nuts. Then with a torque wrench, tighten each fastener to the torque specified in the installation guide. If additional grease is necessary, adding this grease can be done by inserting grease fittings into the threaded holes located in the cover halves. With sizes 1020 through 1090, the grease supplied with the coupling should be sufficient to last until the first maintenance inspection as recommended in the installation guide. Before starting up the coupling, make sure the grease holes are plugged with the grease plugs provided. When the installation is complete and the equipment is aligned to meet